Hello world, I'm Evan Gudmestead, an instructor of application and web development at Rankin Technical College. In today's Code Along tutorial, we are going to build a test score tracker and really hone in on data binding, the benefits of data binding, and how to apply data binding in a .NET MAUI app. Here's a quick demo of the app where you can do a few operations on various test scores. Reading, adding, and deleting these test scores. But again, we're really going to focus in on data binding. So what are the benefits of data binding? How do you bind a C# collection to a UI control? We're going to implement, as demonstrated, create, read, and delete operations. We're going to use an observable collection, which will be new to my students of type T. That will enable us to do that data binding, and we will introduce this concept of MVVM into our applications. I encourage you to code along. I hope you enjoy. Before I dive into the code, real quickly I want to touch on the theory and what are the benefits of data binding. But in order to understand those benefits, we should first define data binding. So the first bullet here is, what is data binding? And you can see here it is connecting or marrying a data source. So in our world, that's a C# collection. If you've worked with an arrays, more specifically a list, if you ever work with lists, that is a C# collection. So taking that data source, taking the data source, the collection, and marrying it to the user interface. And so by updating one, you automatically update the other. And so again, it kind of goes two ways. It's a two-way street. If you update the user interface, it can update the data source. But if you update the data source, it can also update the user interface. And so a simple analogy would be in your house. I'm sure you have a digital display. And you have a thermostat. And so I have a Google Nest, right? And so the thermostat will kind of read the temperature of the room, and it will send the data, that's your data source, to the digital display. And so it'll read that, but also that digital display can be used to adjust the temperature in your house and you know, raise that temperature or change the data source, change the temperature in the house on the back end. So again, I really like that analogy of a digital display being the front end user interface and the thermostat ultimately reading the temperature out of a room. And so why is this useful in MAUI? I would break that answer down into two parts. Number one, it's automating a task. And the task is when the data changes, it automatically updates the user interface. And so what I'm looking at here quickly is a prior MAUI app that my class has coded, and you can kind of see we're adding a score. And what happens is we do some statistics, and then we have to manually update the user interface. And so this task is automated now. This manual, had to cough there. This manual process of updating the user interface is now automated when you use data binding. And so I kind of think of it in back in the day, this concept of garbage collection. You used to have to manually return the memory from your application to the operating system. And so you had to code that. But then Java came around in the 90s and garbage collection was just automated. And so you could think of updating the user interface as kind of like another step in that direction. We're automating this task of updating the user interface whenever the data source updates. Additionally, this is just the trend. So that's one answer, but I would also say, why is this useful in MAUI? This is just an industry trend. When you look at front-end frameworks like React that do this same, what is referred to as declarative programming. And so React is known as a declarative framework. And when you implement binding in MAUI, It's just following that industry trend of, again, what's referred to as declarative programming versus the alternative style where you're manually updating the user interface, which is referred to as imperative. So imperative versus declarative, regardless, it's an industry trend. So those are why it's useful in MAUI. Wanted to cover those concepts before we start coding, but now let's get into the code. All right, let's get the app started by opening up Visual Studio Community. Now I'm going to create a new project. If you've never created a MAUI app before, I do my code demos on Windows. You will need Visual Studio Community, and I'll link to a prior video where I show you how to get basically the MAUI templates installed, as well as get your machine ready to run Android emulators, because there's a few steps in that process. Let's build a MAUI app, and then this button here tells us where. My class is on chapter 8, where we start dealing with arrays and collections, which is why I'm doing this tutorial, because this is a collection. So I'm going to put this in the chapter 8 folder, and I like to check this box here to place the solution and project in the same directory, and I will call this binding demo. .NET 9, we'll click create and let that spin up. All right, let's close the overview, open up the main page.xaml. I'm going to delete everything that's inside of this scroll view. And I'm going to do a little layout of a vertical stack layout with a little padding, call it 20, spacing of 15. And then, so top to bottom, the controls are basically going to go top to bottom, except for my first couple of controls, which will be a label, a text box and a button. So these two controls I want to go side by side, so I will do a horizontal stack layout. Okay, so these are going to be my first couple of controls. An entry control, my text box, and give it a name of, I always do txt add score. So that's the name of my text box. Okay, this forces a Android or mobile device to be a number. Kind of send a width request of 150. And it's a self-closing element. And button equals button add score. Text of add, and we clicked. And let me double click this new event handler, and that creates the name of the control, button add score underscore clicked event handler. And that was a little thing I learned along the way thanks to a little YouTuber comment. So if I go into main page XAML, that event handler has already been wired up, which is pretty cool. So we can delete this event handler. We're not using that anymore. Now this is the event handler. So again, I had to give it a name. And then when I do the click, I just click to wire up that event handler for me. So that's cool. Okay. Now the control that we're going to, ultimately we're going to have a list. It's not going to be a C# list, but think of it as a list of test scores. And we're going to bind that list to a user interface control. So what is that? That's going to be a collection view. And this will be CV collection view scores is the name. And I'm going to set the selection mode to single. Now we're not going to be selecting any of these scores, so I could probably leave that selection mode out. Just want to get that collection view kind of ready to go, because this collection view ultimately will be displaying our list of scores. And so let's create that list of scores in our C# class. We're going to do this by the keyword public. And so this makes it so that our list is accessible to the XAML file by marking this as public. And we're going to have an observable collection of ints called test scores. Now this isn't what's referred to as an auto-implemented property. We haven't covered properties in this class yet, but we will soon. But for right now, we'll just code this get and set block, and we're going to start our observable collection. This is just the syntax to pre-populate some data. So I'll do my first test score is 85. Call this our seed data. These are our test scores, and this is the syntax, okay, for getting an observable collection of test scores. Now let me talk a little bit more about observable collection. So I pulled up a document here of the common C# collections, their characteristics, and their typical use cases. Arrays are one of the, earliest data structures that you will store data in. They're fixed size, meaning they only have so many elements. And they're very, basic in the sense that they're in most programming languages. You use them when you know the exact number of elements you need to store. And they're pretty good performance-wise, because even when you get into these other things like a list, behind the scene, arrays are, a list is actually an array behind the scenes. If you actually dig into what is a list and how is a list actually created, you actually have arrays underneath lists. And so a list is ultimately an array, but it's a dynamical sized array. So you have a list of ints or a list of strings. You can have these things called sets, like a hash set. So if you want a list that has unique elements, you can't store the same element twice. That's where you get into a hash set. Sorted set then is a unique items kept in order. Dictionaries, if you want to look something up by an identifier, like literally think of a phone book, you can look someone up by their last name to quickly access information. That's where dictionaries become useful. Queues and stacks, all the way down to observable collections. Observable collection is why I opened up this document in the first point. Is a dynamic collection that provides notifications when items are added, removed, or when the list is refreshed. When do you use it? You use observable collection for data binding, because again, it can provide notifications when that list is added, something is added or removed or updated. Okay, so specifically observable collection, a list of ints would not be used for binding. If you want to bind that, if you want to have that two-way communication of binding, we actually have to use an observable collection. Okay, so basically in .NET MAUI, if we're going to do binding, we're going to use an observable collection. And so that's why our list is essentially, you could think of this as a list, but this is more for data binding. So here's our test scores list. Let's put a semicolon at the end. Okay, now let's go back to our XAML file And let's bind this with an items source. You put curly braces here, binding to the test scores. Okay, now because test scores was made, this is a property on the code behind file, and it's a public property. You can bind a control using this syntax here. Okay, but there's one more step. In this line here, the main page, this is referred to as a constructor. Again, if you're in my class, we haven't quite covered constructors yet, but we need to actually set the binding source, binding context to this. Okay, and so what we're doing is we're basically setting the main page to bind to the instance of the main page class. Okay, so this binding context, well, we can see here, to enable data binding. Without this line, this data binding feature would not work. And so sometimes you want to use what's called a view model instead. So this main page is acting as a view model. I'm not actually creating what's called a view model because this is less code and probably kind of simpler to get started using binding by just setting the binding context to this. But what is a view model? A view model is a model is a C# class that will be used by a view. And so I would have to create another class, and it's just easier to set it to this. Okay, so let's go here back to my collection view. This sets my item source. There's a few more lines here. So this basically says, hey, the collection will be used in this collection view, and I'm going to bring in a few more tags. Okay, so for each item, there's a template for each item in my list. Okay, so the way I look at this is you have a collection view, and in that collection, we're going to be viewing a collection. There's going to be a bunch of items, and for each item, there's a template. Okay, and this is that template. We're going to stack some controls horizontally. So for each item, we're going to put a horizontal stack layout to go across the page. And there will be a label where the text is equal to, and we're going to bind the text. So think about each item is going to have you basically say bind it to that item's text. So each item, put that item's text into the label, and in this case, the text is just the number. So put the number in a label, essentially, is what that's doing. And we'll do a font size. Do a font size, vertical options of center. Okay, and then for each item in the collection, we'll have a label that displays the number, and we will have a button to delete. So the text is delete. Now, I'm not going to give this button a name as I did this button because you're going to have a bunch of buttons here, right? These are a bunch of individual buttons, but each button will have to wire up an event handler or event listener to say on delete score. So I'm going to have to manually code that. there's going to be a command parameter. So this will send the number into this method as a command parameter. So again, each test score can be sent in as a command parameter. This is a property. So I'm going to come back to that command parameter in the code behind. The background color of this button will be red. The text color will be white. And with request of 70. Okay, so close a button, close the horizontal stack layout, close the data template, close the collection view, close the vertical stack. Okay, so at a very basic level, we are now binding our test scores property and displaying those test scores in our data template. I'm going to see what's broken, and let's boot this up in my Windows machine. So I oftentimes have to click the play button a few times. As far as I can tell, that's just part of MAUI. Getting it to launch, I sometimes have to click it a few times. So let me click it a few times to get this thing booted. Well, of course, let me fix my build errors first. I need to create this method called onDeleteScore. So the method signature is going to be very similar. Private void onDeleteScore clicked, and I'm not going to wire up that. I'm not going to wire that up. So this is onDeleteScore clicked. Let's see, close. Let's not lose this curly brace. Okay, now let's do a build. I just realized I didn't put the underscore clicked like the other one did. This one's just called onDeleteScore. onDeleteScore versus button score. So my convention, my naming convention is not consistent, which is why I need to clean that up. But nonetheless, let's build it again. Now we're building correctly without errors. I need to get my naming conventions consistent, and that's a mistake. Not a critical mistake, but it is a mistake. All right, now we can click to boot up now that it's building. I always like a good hot reload. However, we can see my controls. Now my add button's not wired up, my delete button's not wired up, but you could see the binding at play. Okay, so, you know, we've covered the benefits of binding. We had a property, and that's the key thing that I want to kind of mention is that, you know, in order to bind, we needed to bind to a property, and that property belongs inside of a class. And I realize my current group of students we have not really covered properties yet, but that's coming. This property is an observable collection. There's my data. And I mentioned in the objectives a Model-View-ViewModel is a pattern where the model is separated from the UI. So again, a model typically is a C# class. This class is acting as our model. And you know, the way I think of a Model-View-ViewModel pattern is just where you have a class that has that two-way relationship. So between the data and the UI. And so I guess the thing that I want to reference here, the thing I want to point out is that technically speaking, we are implementing MVVM, which is to say that this main page is a class that's being used as our model, and then so the model is going to be sent into the view, used by the view, and that the view has a model. So that's a long way of trying to explain that we are actually already implementing MVVM when we're coding in this manner. Now, I'm going to expand on this in the future in this MVVM. Instead of setting the bind context to this, we will use a view model, and therefore it'll be a little bit more apparent that this binding MV model view model and how that all works. But long story short, this is technically implementing that pattern, and we will see more of that in the future. All right, so I'm gonna do a if statement, and if I can try parse my text add score dot text into a variable called new score. Let's fill this in. Okay, so we're doing a little data validation here. We're going to try and convert the text box text into an int. If it works, it puts it in a new variable called new score. We then add new score to the list. And this line right here will automatically update the list view due to the data binding. Okay, now here does clear the input field after adding. This was, that's not needed, but you could do that, of course. And this offers that benefit of automatically updating the UI. Okay, however, if the new score, it also has to be greater than or equal to 0 and less than or equal to 100. So if it's a negative number or greater than 100, we're not going to add it. In that case, if any of those conditions exist, we'll give an error message. Save that, boot it up on a Windows machine. And if we do 101, we should get an error message. If we do a negative 101, we get an error message. If we put in the letter A, we get an error message. If we put in a valid score, it automatically updates that user interface. It did clear the text box, but notice that is one way. That is from the user interface to the data source. That is one way of the two-way street. All right, so we were able to put data in with this add score. Now, the line of code to delete, we'll do another if. Now, this is really interesting here. This is a little bit different. Okay, so when we have an event listener like this, we have what are called two parameters. These parameters is object sender and event args e. Sender represents the control that initiated the event. We're going to remember that we're clicking a button, right? That particular button is the sender. There's a bunch of buttons. There's a bunch of delete buttons. So whatever button we click is the sender. There could be 10 delete buttons, but only one is sender. Okay, so sender, the first thing we do is we see if sender is a button. And if sender is a button, then we kind of reference that button and we call it lowercase button. So it's an if statement. If the sender is a button, we're calling it button, and the button has a binding context, remember that's the data that we put back here. The binding context, this command parameter, then that is an integer score, right? So keep in mind that will ultimately take the score and you convert it to an int and you put it in this variable called score. So again, you could just think of the binding context as the actual data that, notice we're binding the data here through this command parameter attribute. We're just taking the number, the 100 test score, and passing that in as a parameter, and then we read it using binding context. Okay, and if that's the case, that the sender is a button, and you can convert the data that's bound to that button into an int, then here, I don't want to miss this, but this test scores, we have an add method and we have a remove method. Remember, test scores is our observable collection. So when you call this add and you call this remove, this automatically, these two methods will automatically update the UI with the updated test scores. So remove the test scores from the collection and automatically update the list view. It's not a list view, it's a collection view. Otherwise, and look, I don't see too many scenarios where this else block runs. Not to say that they don't exist. So let's run this and add a valid score and delete that score. Awesome. So I just wanted to introduce data binding. I know, you know, this is mostly a simple app. It's not the most, complex app in the world, but this is a good introductory topic in .NET MAUI. I want to thank you for your time. I hope you enjoyed this code along, and I hope you learned about binding in .NET MAUI. Hmm.